Now we are ready to begin some statistical analyses on this data set. We are going to start with a simple analysis approach, and that is a t-test. And we are going to investigate whether volatile acidity is different, significantly different, between wines that were rated as quality 3 versus quality 8. So what you want to do is grab all the data values for volatile acidity for quality 3 and quality 8 and plot them like this. You can see I'm plotting them as dots, and I also have these random x-axis offsets. That's just to help minimize the overlap between the different dots, so they're just a little bit easier to visualize. Also just kind of looks nicer. Okay, and then you do an independent t-test on these. So not a paired samples t-test, we want an independent t-test. You can find the t-test functions in the stats library of the SciPy module. So you want scipy.stats. And then here in the title, you can print out the t-value and the p-value corresponding to this test. So this is a highly significant difference here. So somehow quality is related to volatile acidity. If you're wondering what volatile acidity in wine means, then don't ask me. I have absolutely no idea. But I'm curious, if you are an expert on wine, then please do post the Q&A and tell us all about volatile acidity. There's actually several different forms of acidity in this data set. Anyway, now remember that this data set has almost 1,600 values, almost 1,600 rows or observations or ratings. And yet this scatter plot has very, very few data points overall. So that seems a little weird. So to get more insight into what's going on here, you should look at a histogram of the quality ratings. So this shows all of the counts of the number of rows with these different quality ratings from 3 up to 8. And what you see here is that there are actually very, very few wines that were rated with a low quality, and also very few wines that were given a very high quality score. So therefore, what you should do next is repeat this t-test, basically the same thing, except now you're going to pool together all of these two quality ratings, so 3 and 4, and pool together 7 and 8. So ignore 5 and 6 for now, but just come up with groups of 3 and 4 and 7 and 8. And then your graph will look something like this, where you see these two lowest quality rated wines and these two highest quality rated wines. Now what you can also see is that I've added these black outlines on top of the dots here. Totally unnecessary. I think it looks nice. So you can see if you can replicate that. Of course, the statistic value is going to be different, so you'll need to recreate this plot entirely. All right, so those are all the goals for this video. Good luck working through this, and pause the video. And now I'm going to switch to Python and walk you through my solution. So the first thing I need to do actually is import the stats module. So I'm going to write import scipy.stats as stats. We'll give it that alias. And let's see, waiting. Okay, there we go. No problems, no misspellings. We're all good here. Okay, so let's see. The first thing we need to do is extract the data. So extract data. Now for convenience, I'm going to put these into separate variables called x and y. So this is going to be data, and we want volatile acidity. And except this is not exactly what we want, because so far this is all of the data points. This is going to be almost 1,600 data points, and that's not what we want. We only want the acidity values where quality is equal to 3. So the way that I'm going to do that is by another set of square brackets here, and data quality equals 3. So this is going to evaluate to a Boolean, and it's just going to select the rows in this vector where quality equals 3. So now let's see what we get. So now you see we get a much tinier data set. Now, when you first look at this, you might think, wow, there's still 1,500 data points here. But in fact, these are the row numbers, not the number of rows. So you can see it's not going monotonic, or it's not going incrementally. So in fact, we only have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points here in total. Okay, so that was for x, and now variable y is going to be basically the same thing, but it's just number 8 instead of number 3. Okay, so now we're going to do a t-test, but first I want to create a plot. So plt.plot, and I'm going to say numpy.random.randn. So I'm generating random numbers here for the x-axis coordinates. So that's going to be, oh, I see I made a typo here. That should be y. Okay, so randn, this is going to be length of x, and then by x. And let's make that a circle. So let's already see what this looks like. So this plot is all over the place. There's quite a lot of spread in here. So what we want to do is basically turn this down a little bit. So I will say, how about divided by 30, something like that. Now, it's still going to look like it's really spread out, but you can see now the x-axis range is really tiny. It's just minus 0.04 to plus 0.04, basically. So let's see. So now we could write for y, we could write a whole other plot line, but I'm going to do something slightly different. I will say comma, and then over here in the next line, numpy.random.randn. Now this would be an easy mistake to make, to write something like this. And why is this wrong? Well, this is wrong because we cannot assume that the length of x is the same as the length of y. So this is almost certainly going to give us an error. Yep. So let's change that to length of y. And now, okay, so now they're all intermixed. They're all intermixed because they all have a mean of 0, or all of these random points have a mean of 0. So let's add 1 to this. So I'm going to offset these. This is looking better now. Let's see. Now I will change the x limit. So plt.xlim. And I want to go from, it's going to be -1 to +2, so that there's 1 unit to the left of the blue dots and 1 unit to the right of the orange dots. So -1 to 2. And all right, this is starting to look good. So now, but these are not actually numeric labels. So I want to change the ticks. So let's say plt.xticks, and I only want to show tick 0 and tick 1. And then, of course, these aren't called 0 and 1. These actually have names. So labels equals qual3, put a space there, and qual8. All right, and then we need a y-axis label. So y label is volatile acidity. And very good. So now the plot looks really good. I'm pretty happy with how this plot looks. Of course, we need to run the t-test now. So let's see. So to run this t-test, we use the stats.t-test. And there's a couple of different types of t-tests that we can use. There's the one sample independent. This is dependent samples or related samples. In this case, we want independent samples. And we input x, comma, y. And that's going to run an independent samples t-test between x and y. If you're not familiar with the t-test, then basically all we're doing is testing whether the mean or the average of these data points is different from the mean or the average of these data points here. Okay, so let's see. So we need an output of this. Let's call this t-test. And let's inspect this variable a bit. So let's say print out t-test. So we can see the t-test result is, it's a tuple. The first value is the statistic value that's related to the difference in the size. And then we have the p-value, which is this really, really small value. Okay, so we want, let's see, this is going to go in the title. So plt.title. And I'll also use a f string here because I did in the previous video. So t equals stats 0. So the first element in stats. And the p-value is t-test. Oops, this is called t-test, not stats. T-test and this is t-test 1. So this 0, this is the first element in this t-test tuple, and this is the second element here corresponding to index number 1. All right, so let's see how this looks now. Okay, so this is really, really long. Get rid of that print statement. This is a really, really obscenely long title. Let's get this back. Come on, Colab. What is it doing? It's really thinking hard about this t statistic here. Okay, this is, extremely high precision, basically way higher precision than what we need. So how can we go about just showing the first couple of digits here? So you might remember from the first part of the course I showed you, you can do something like 0.2f. So this is going to give us 2 decimal points or 2 digits after the decimal point, and the f here is for the formatting. So that looks good for the t-value. And for here, maybe I'll go with a little bit higher resolution, maybe 0.5 or higher precision. All right, this looks good. I'm going to say that this is a successful completion of this first part of the video. And by the way, we're probably around halfway through the video now, in case you want to get up and take a break or drink a glass of water or something. So the next thing we want to do is make that histogram plot that shows the number of times that each of these quality metrics or quality values appears in our data set. Now, there's 2 ways that you can go about doing this. There's a slightly longer way and a slightly shorter way. I'm actually going to show you both ways because I think they are both useful to know about. The shorter way is obviously, the way that you should prefer in practice, but the longer way is also going to help us think about Python coding. It's going to help us think about for loops, and it's going to help us work through working with pandas and being more comfortable working with the pandas data frames. Okay, so I'm going to show the longer version first. So I'm going to initialize a variable, a vector called qual counts. It's going to be 0, 6 zeros, because I know that there are 6 unique values in the quality column. So let's see. Now you already know that we can do something like this to get all of the data points just from this column. And furthermore, you also know that we can do something like this to get all of the data points that have a quality rating of 3. So in this case, this is actually showing us the entire data set where we just have all the rows where the data quality is 3. You can see that at the last column here. Okay, now we don't actually care about all of the data. What we want to know is the number of rows in this sub data set. So this data set where all the quality values are 3. So therefore we can write the length of this data set. So there are 10 data points that have a quality value of 3. So we could hard code this and repeat this, 4, 5, 6, 7, 8, and so on. Or I'm sure you're thinking the right thing, which is to create a for loop to do this. So let's say for I in range, and now I'm going to range from 3 to 9. It's a little bit of hard coding here, but we already know from earlier, from the previous video, that the quality ratings go in integer units from 3 through 8 inclusive. So here we have 3 up until 9. This is an exclusive upper bound. So let's see. We want qual counts. And now how are we gonna index this? Well, we cannot index it with I. This would work for the first couple of iterations, but it'll eventually crash because this only has 6 elements in here, and eventually we're going to try and access element, the 7th element in here, which is not allowed. So what I'm going to do is create a new counting variable called n, and then set this to be element n, and then we need to increment n like this, and that's going to work. Okay, so now we can have a look at this, and this tells us, okay, this is good that we inspected this, because now I see that there's a mistake in here. I left this hard-coded at 5. Here you see, by the way, exactly the problem of hard-coding things in Python. Of course, I hard-coded this here, but that's okay. Okay, so now this looks better. All right, and now I want to show a bar plot So I'm going to use range 3 through 9 and qual counts. And here's our bar plot. That looks good. And then I will say plt.xLabel is the quality rating. I'm just going to, making this plot look a little bit nicer. YLabel is the counts, and plt.show. All right, this looks good. So as I mentioned, I like this approach because it forces us to think about working with methods that act on and ways of working with pandas data frames. That said, there is actually a simpler way to arrive at this same result, and that is to create a new data frame called data, so let's see, data quality dot value counts. And what this is going to do, value counts. What this is going to do is count all of the values that we have in the data set. So in fact, you can see this gives us, now it's not in the same order, it's in decreasing order of count, but the labels match, of course. But this is all the same information that we extracted here. So this is really great. So we can say counts equals this thing. Let me spell counts correctly. And then plt.bar. And actually, let me show you how we're going to work with this. So we have this variable counts now. And what we want to do is plot this column on the x-axis and this column on the y-axis. Now we can access the first of those columns with keys because, in fact, this is still a pandas data frame here, even though it contains a lot less. It doesn't contain the raw data anymore. It's still a data frame. So the keys, and then we get the list of those keys, and that's going to just extract this information here. Okay, so this is a list of all the keys. Now this is not in order, but it's totally fine because the variable counts, this data frame counts, this is also out of order in the same way. So it's actually going to be fine. So now I input this into a bar plot. And now you can see we get exactly the same thing, but with basically just 2 lines of code instead of however many lines this was. All right, so remember why we're doing this. We're doing this because we were surprised to see so few data points here. And maybe this is too few data points to really give us a reliable answer to this question of whether volatile acidity is related to wine quality. So therefore, what we want to do is repeat this t-test, but grouping together quality 3 and 4 and grouping together 7 and 8. So to do this, I am going to copy all of this code, paste it down here, because what we want to do is more or less the same thing, except we want to get more data out of here. So how do we do that? So there's a couple of ways that we can do this. You can say less than 5, which includes 3 and 4. It would, if this data set also had quality ratings of 1 or 2, it would also get included in there. I'm going to leave this as equals 3, and I'm going to say, or data quality equals 4. So let's see, like this. And then same thing here. So this is going to be now 3 and 4, and so x is quality 3 or quality 4, and y is quality 7 or quality 8. Okay, so then let's see. I believe the rest of this is fine. So this would be quality 3 plus 4, and this will be 7 plus 8. All right, so we get a little, this is actually a syntax error. This is slightly confusing error message because it turns out that what we need to do when you're using Booleans here to access multiple features, you just need to encase them in parentheses. So that's the solution if you see an error message like that. And what am I still doing wrong here? Ah, right, I see. Okay, it actually needs to be, so this is a pretty weird Python syntax, pretty particular, but it's each expression individually needs to be encased in a parenthesis like this. not the whole thing in parentheses, but each individual statement that you want to make has to be in its own set of parentheses. All right, so now that works. And the only thing that we're missing here, you can see the t-test also got updated. The only thing we're missing is that I added the little outlines, the black outlines around each of these dots. So to do that, we can add an additional optional input here, and that's called marker edge color. And I'm going to set it to be K, which stands for black. So there we go. And I will call that the successful completion of this video.